Now, while it's true that the best way to learn how to code is to actually write code, and trust me, we're going to write some code here very shortly in the course, but if you're watching in order, you're kind of thinking, we're doing an awful lot of chalk talk here, and it's getting a little bit confusing. Hang in there. I just want to kind of explain this stuff to you, and it will come back to life a little later on when we start working with some of this stuff in code. But this information is foundational to understanding how C# does what it does, and this can really separate a really good, efficient programmer from one who's not so efficient, and it will really come into some design issues later on. So hang in here with me, okay? Let's talk about in this video understanding types. Now, the best way to understand types is to think about what exactly do programming languages do? Well, when it's all said and done, they collect data, they store that data in memory, and they manipulate that data, and then of course they may store that data somewhere else, they may write it into a database, they may do all kinds of things with it. Now, there are many different kinds of data that we need to collect, store, and manipulate, right? We may have to just grab very small numbers, or we may have to use very large numbers, or we may even have what we know of as decimals, which is, numbers with decimal places, or fractionals. We may have collections of data like objects or lists. We have a lot of items that are related to one another, and this just goes on and on and on. For each one of these different types of data, we need to first of all know how much memory to set aside to store these, because we have a fixed set of memory available to our applications on our computers, and it also makes it more efficient for moving these around. Think about storing things in your garage or your attic or your closets or whatever. If you're going to put things in boxes, you want to fill the boxes up. You don't want to store a bunch of half-empty boxes. You're storing a lot of blank space. And then when you start trying to look through that stuff for things, you waste a lot of time looking through blank space. The same thing happens in your computer memory. And so types help us deal with that issue. Each different, unique, specific kind of data must conform to a set of rules about that data. Now, a type can be thought of as a set of rules and functionalities that governs any item or data that utilizes memory in our C# program. Now, C#, if you read the documentation, will tell you straight up it's a strongly typed language. What that means in English is each type of data that you're going to use in C# has to be predefined, and each piece or collection of data used in the program must be identified by a certain type, and C# is going to really police you here. And certain operations can only be done with certain data types. Data types have strong limits on the amount of memory they can use, and so forth. Now, just notice here, for example, 2 plus 2 is 4. So if we take two integers together and we add them, and we're going to come up with another integer. All right, what about this? 2 plus a car. What does that mean, right? And so we have to make sure that our data types are both, for all the data types that are used in an expression, some sort of mathematical computation, are data types of the same or similar types that can be used to provide a meaningful result. Now, the information stored in a type can include the following. So when we look at a data type, for example, in C#, that is going to determine the storage space that variable requires. So how much memory is it going to take to utilize a variable that's of the integer data type, the maximum and minimum values that can be stored or represented by that memory location or by that variable, the members, methods, fields, events, and so on that it contains when we're talking about things like classes and structs and so forth, the base type that it may inherit from. We'll talk about inheritance a little later. The location where the memory for variables will be allocated at runtime. We'll talk about that when we talk about value and reference types, and the kinds of operations that are permitted with this particular data type. So just by assigning whatever we're trying to store in memory with a particular type, a particular data type, we are making it basically that type, and it's going to fall under certain rules and regulations, and that just makes our programs very safe, very stable, very predictable. Now, C# really breaks all the types that are out there into two main types: value types and reference types. Now, these are subdivided from here, but for now, don't worry about that. In C#, you have two main choices. You can store data in a memory location as a value type or a reference type. Now we're going to take a closer look at these in a video entitled Value and Reference Type. So you may want to go take a look at that one next. Okay, that's the bottom line on types. Just understand types define exactly what conditions, rules, and regulations are going to be applied to a particular piece of data that we're storing in a particular variable.